Hi, I'm Tom Biebighauser with Wetland Restoration and Training. If you've been out on a site looking for a place to build a wetland, maybe you have not been able to find clay, maybe there has not been groundwater anywhere near the surface, but you still want to build a wetland. Well, this video, I'm going to show you how to use a technique that allows you to build a wetland anywhere on the landscape. It's called the aquatic-safe liner technique. And I'd like you to look at this beautiful wetland behind me. Isn't it gorgeous? That was built using an aquatic-safe liner over 11 years ago. And it looks and it's functioning just like a natural wetland. So today we're going to dive in and see how we can use the latest technology to build naturally functioning and appearing wetlands by using aquatic-safe liners that are buried in the ground. And these wetlands are going to last for hundreds of years. So stay tuned and let's get started. I helped build this wetland using an aquatic-safe liner at Mass Audubon's Chiricahua Wildlife Sanctuary located on Cape Cod, Massachusetts. Here's another wetland we built using the aquatic-safe liner on Mass Audubon's Chiricahua Wildlife Sanctuary. The eastern spadefoot, a rare species, is using this wetland and others just like it for breeding. We built this wetland with the help of students at Mill Creek Elementary School in Lexington, Kentucky. You're looking at one of 6 wetlands we built in an abandoned section of the black-topped sea-to-sky highway in British Columbia, Canada. We built this wetland as part of a hands-on wetland restoration workshop that was hosted by the U.S. Fish and Wildlife Service at the Wolf Creek Natural Fish Hatchery in Kentucky. And this is one of 2 wetlands the Boy Scouts dug by hand and then installed liners at the U.S. Forest Service Office and Visitor Center near Farmers, Kentucky. We built this wetland using a liner on a rocky log landing on the Danube National Forest in Kentucky. Here's a 1-acre wetland we built in North Carolina. We used an aquatic-safe liner, and the wetland now provides breeding habitat for the gopher frog, a species listed as endangered by the North Carolina Wildlife Resources Commission. I started working with the U.S. Forest Service in 2015 to design the California red-legged frog habitat expansion project near the community of Michigan Bluff on the Tahoe National Forest in California. Dan Teeter, the aquatic biologist on the American River Ranger District, he and I designed the project to provide breeding habitat for the federally threatened California red-legged frog. We designed a total of 20 wetlands that could be built to provide habitat for the California red-legged frog. Designing the project was a real challenge because there were very few places of flat ground where we could build wetlands in the mountains. We designed the wetlands in tree canopy gaps where it would be possible to move an excavator between the larger trees so that we could access each construction location. A laser level was used to identify areas for building the wetlands that had no more than a 3-foot change in elevation from the upper to the lower edge. We used a 4-foot-long tile probe and a 4-foot-long soil auger to measure soil texture and the depth of soil to bedrock at each site. The perimeter of each designed wetland was marked using plastic ribbons. A wooden stake was used to mark the center of each wetland to be built. Because of the rocky and the sandy soil and the total lack of groundwater, we found it necessary to use liners to build 16 of the 20 wetlands that we had designed. Dan and I agreed to use only liners that were certified fish grade and aquatic safe to build the wetlands. We purchased the aquatic-safe liners from DAC Liners in Oklahoma. The liners were fish-grade 30 mil PVC and one-piece factory seamed, and they measured 40 by 40 feet to 60 by 60 feet. It was not possible to build larger wetlands because of the steep slopes that were bordering each site. In the year 2021, we built 18 wetlands at Michigan Bluff. 16 were built using aquatic-safe liners, while 2 were built using the compacted clay liner technique. Dan Teeter served as the project manager. Don Smith skillfully operated the excavator that was needed to build the wetlands. Don and I had worked together to build hundreds of wetlands across Arizona, California, and Nevada using aquatic-safe liners that are now providing habitat for rare species of animals and plants. Over 100 volunteers and personnel from 5 nonprofit organizations and government agencies assisted with the project. This photo shows one of the locations where we plan to build a wetland using the compacted clay liner technique. And here's how the wetland we built using the compacted clay liner technique appeared 3 years later. There were an amazing number of Sierra and tree frog larvae using this new wetland that we built using the compacted clay liner. It's highly likely that the California red-legged frog will find the new wetland because it's using other wetlands we built nearby. Here's how the second site appeared before we built the wetland using the compacted clay liner technique. And this is how the wetland looked 3 years later on May 17th, 2024. Before construction began of either wetland using the compacted clay liner technique, we used an excavator to dig a deep test hole near the center of each area. The test holes confirmed that the soil was high in clay and the clay was in a layer about 5 foot thick. But unfortunately, during construction, we found that the clay at the second site was in patches and it was not uniform across the whole area. The clay that we dug out of the ground in the second wetland was also too dry to compact effectively. We had no way to bring in water to moisten the clay. Because we could not find another source of clay and we did not have an extra aquatic-safe liner, we went ahead and built this wetland and hoped for the best. Monitoring by the Forest Service showed that the second wetland we built, where the clay was in patches, only held water a few days after a heavy rain. After much discussion, we decided to install an aquatic-safe liner to repair this dry basin. The day of construction, we used a 100-foot long tape measure, a center stake made out of rebar, and wire flags to mark an area on the ground that measured 60 feet in diameter. Pink-colored wire flags were placed to show the excavator operator where to dig to install the liner. We hired a local contractor to provide an excavator with a skilled operator to build the wetland. The excavator was a CAT 328D LCR, and the excavator had a 204 horsepower and it weighed 72,500 pounds. The machine had a thumb attachment that we could use for picking up logs and rocks. The CAT 328D excavator was the perfect size for the job. The machine had a large bucket with plenty of power so we could move a large quantity of soil. This excavator could reach 26 feet with this bucket. This was very important for placing soil over the liner without having to travel on the liner. Hiring a skilled individual to operate the large excavator is critical for building a wetland with a liner. We set up a laser level and took elevation readings to identify how much elevation change there was between the upper and the lower edge of the marked perimeter of the wetland that we wanted to build. I recommend that when building a wetland of any size with a liner, you have and you know how to use a laser level or an optical construction level. We showed the excavator operator where the basin should be dug for the wetland. We also discussed where the soil removed from digging the wetland could be piled and spread. We decided to level the area where we wanted to build the wetland prior to digging the basin for the wetland because there was more than a 3-foot change in elevation between the upper and the lower edge. The excavator began work by picking up the logs and the treetops we had placed in the clay basin and then moving this material outside of the area where we were building the wetland. Next, the operator levels the work area because there is more than a 3-foot change in elevation from upper to lower edge. Once the area was leveled, a rebar stake was driven into the ground near the center of the wetland that we wanted to build. Now, in advance of construction, I recommend purchasing 3 sections of rebar that are 1/2 inch diameter and 4 feet long. You'll also need a tape measure that's at least 100 feet long. Make sure that the end of the tape will fit over the rebar. Pre-cut sections of rebar are available for purchase at most home improvement stores. Having more than one piece of rebar is important because the excavator is likely to bend one or more pieces during construction. It's also important to purchase or to borrow a 2.5 pound or 3 pound handheld sledge that you can use to drive the rebar into the ground. You'll need at least 3 of these sledgehammers because later on you'll be driving in 12-inch long landscape spikes and will be using it later to anchor the top edge of the liner in the geotextile. The end of the tape is placed over the rebar. Because we're installing a liner that measures 60 by 60 feet, the tape is stretched out to a radius of 30 feet. One person stretches out the tape to 30 feet while the other person places wire flags in the ground that are about 10 feet apart as they walk to mark the perimeter of the circle. It's most efficient to install a liner with a simple round or an oval shape, and then later place soil in the basin to vary the edge and the bottom compared to trying to cut and shape the liner material over a very irregular surface. The wire flags now mark the perimeter of the wetland to be built. A laser level and a dual-sided grade rod are used to take elevation readings at each flag that we had set in the ground to mark the perimeter of the wetland to be built. This was done to identify the lowest place along the perimeter of the wetland we are building. The highest number read on the grade rod is going to equal the lowest place along the marked perimeter. You need to write this number on a piece of paper as it will be used frequently the rest of the day. The highest number read on the rod is very important because it will be the same elevation reading where we will trim the top edge of the liner, and it will be the same elevation reading as the water level in the wetland that we are building. We now place offset flags to help us remark the exact center of the wetland we're building. The center of the wetland we're building will need to be remarked after we temporarily remove the rebar stake so the excavator can dig a hole in the center of the wetland, and this hole will serve as a guide in digging the basin. 3 people are needed to place the offset flags. One person holds the handle on the tape measure, another person holds the end of the tape measure, a third person stands in the center next to the rebar stake. The tape is stretched across the marked wetland perimeter. Because the wetland we're building is 60 feet in diameter, the person in the center makes sure that the number on the tape reads 50 feet with the tape just barely touching the center stake. The people holding the tape stretch it tight and place wire flags in the ground. One wire flag is placed at 0 and the other is placed at 100 feet. The 2 people holding the tape now move and stretch the tape at right angles to the first setup. This is like cutting a pie in 4 equal pieces. The people on the ends stretch the tape tight and they place wire flags in the ground. One flag is placed at 0 and the other is placed at 100 feet. Again, the person in the center makes sure that the tape reads 50 feet where it's touching the center stake. It will now be possible to return, stretch the tape between one set of offset flags and remark the center. And then to move to the other set of offset flags. The lines will cross at right angles to each other where the center of the wetland will be built. We can now remove the center rebar stake and replace it with a wire flag that is okay for the excavator to remove when digging the center hole. The next step is to use the excavator to dig a hole in the center, exactly where the rebar stake was located. The bottom of the hole will be the same elevation as the maximum depth in the wetland we're building, plus the thickness of the soil layer that we're going to be placing over the liner in the geotextile. Here's how to calculate how deep you should make the wetland with the liner. The size of the liner and the steepness of the inside slope affect how deep one should dig the wetland. It's important that the inside slope of the wetland is no steeper than 20%. If it's steeper than 20%, soil can slide off the liner and fill the bottom when deer and elk enter the wetland. So in looking at the table here, if your liner measures 60 by 60 feet, the deepest you should make it is 6 feet in the center. If it's 50 by 50 feet, the deepest you should make your wetland is 5 feet in the center. If it's only 40 by 40 feet, you should not make the wetland any deeper than 4 feet in the center. And if your liner is only 30 by 30 feet, your wetland should have a maximum depth of 3 feet. Here's how one may calculate what number to read on the rod and the bottom of the hole that's being dug in the center of the wetland we're building. And this is when we're installing a liner in geotextile that measures 60 by 60 feet. And we want the water in the wetland to be as deep as possible, which in this case would be 6 feet deep. So looking at the table, let's say that you're holding this rod. The typical reading that you take at the low edge of the marked perimeter would be a 6.0 feet. The maximum depth that we know we can build the wetland is 6.0 feet. So the thickness of soil that we want to spread over the installed liner and geotextile is 0.5 feet. So if we add these three numbers together, we come up with 12.5. And this will be the reading on the rod that we want to see when we place the rod in the bottom of the hole that we've dug in the center of the wetland we're building. Now here's a different example. Here's how we calculate the number to read on the rod in the bottom of the hole that's being dug in the center of the wetland that we're building. And this is when installing a liner and geotextile measuring 60 by 60 feet, and the maximum depth of water we want in the wetland is only 2 feet, not 6 feet. So the typical reading on the rod that was taken at the low edge of the marked perimeter is a 6.0 feet. The maximum water depth that we desire in the center of the wetland is only 2.0 feet deep. So the thickness of soil that we're going to spread over the liner in the geotextile we install is 0.5 feet. So now if we add these three numbers together, we come up with an 8.5 feet. Now this is a number that we want to read on the rod when we place it in the bottom of the hole that we dug in the center of the wetland we're building, is an 8.5 feet. The laser and rod are used to measure the elevation on the bottom of the hole. It's often necessary to adjust this depth by adding or removing soil. The three people who place the offset flags can measure again to find the exact center of the wetland being built now that we've dug the hole in the middle. The rebar stake is driven into the ground, into the bottom of the hole, exactly in the center of the wetland that we're building. Now the excavator operator can expand the hole around this center rebar stake, but be very careful not to hit the stake and to knock it over. The excavator operator begins by shaping a ramp with the center stake being at the very bottom of the slope. A short section of the basin is dug to serve as a guide. This is like removing one piece of pie from the pie pan. The end of the tape measure is placed over the rebar stake. The tape is extended 30 feet, which is equal to the radius of the liner that we're placing in the basin. An elevation reading is taken where the tape reads 30 feet. The number read on the rod should be the same as the low edge of the marked perimeter, which is the same as the elevation where we're going to be trimming the liner and geotextile, which is also the same as the water level in the wetland we're building. Here the excavator operator is roughing in the basin by digging out the center, and this is where most of the soil will be removed. At this step, the excavator operator is not too concerned about hitting final elevations. He will soon return to where the outer edge of the wetland is being built and continue sloping and shaping the perimeter to the planned elevations. The soil removed from digging the basin is placed in piles along the edge of the depression, yet away from the edge, but yet within the reach of the excavator. Approximately 1/2 of the soil will be later spread over the liner in the geotextile, but the soil that is not placed over the liner will be spread around the finished wetland so it appears natural. No dams, dikes, or berms will be built to impound the water. Now that most of the soil has been removed, the excavator operator shapes the basin by removing high ridges and mounds and by filling in dips. The next step will be to work around the perimeter of the basin to finish slopes and to hit the target elevations at 30 feet. The excavator operator is now building a section of the basin. Two people stay close to the operator to check elevations at that 30-foot radius mark. The excavator operator is asked to return to sections as needed to raise or to lower the ground where the tape reads 30 feet. It's very important that you work closely with the excavator operator to dig and finish sections of the basin as you move your way around the wetland to be built. The liner you're installing is like placing a large bowl in the ground. If a section of the edge is low at 30 feet, the wetland will be shallower than planned. But if a section of the edge is too high at 30 feet, you'll be wasting liner and the wetland will be smaller than planned. So if we want the liner to fit perfectly when it's first placed in the basin, so it doesn't have to be removed. This drawing shows a perfectly dug basin that will make optimum use of the liner and geotextile. The radius of the basin is 30 feet all the way around, and the elevations are all the same where the tape reads 30 feet. But this is what happens when the laser level and the tape measure are not being used during construction. The wetland will be much smaller than planned, and large sections of the liner and the geotextile will be cut off and wasted. Here's where the basin was made too large. There isn't enough liner and geotextile to build the wetland. Because the basin was dug too large, elevations along the perimeter are too low, and this means the wetland will be much shallower than planned. Here's where wildlife biologist Lauren Hoyle and I check elevations along the perimeter of the wetland that we're digging. After stretching out the tape, we take an elevation reading at 30 feet. We place a wire flag in the ground if the reading is equal to the elevation taken earlier at the low edge of the marked perimeter. Here's where we found a high place along the perimeter of the basin. We were able to lower the soil by kicking it with our feet. Sometimes you'll need to use a rake or a shovel to make a mound that's the correct elevation. If the site is still too high or it's too low, then go get the excavator operator and have them adjust the elevation before they get too far ahead of you. One then places a wire flag in the ground marking the correct elevation to help guide the excavator operator. The excavator operator slopes the basin beyond the wire flags that are marking the perimeter of the wetland we're building. We avoid leaving any drop-off or vertical face beyond where the wire flags are placed because this will make it very difficult to install the liner and geotextile. The excavator operator is asked to remove large rocks and clumps of soil in the basin. We now use firefighting tools to build up low sections along the edge. The flags mark the edge of the liner and the geotextile that we will be installing. Some of the sites where wetlands are built using liners are very rocky. To help prepare the ground for placement of the liner, I suggest asking the heavy equipment operator to drive in and out of the excavated basin with the excavator. The heavy weight of the machine combined with the wide tracks are going to push many of the rocks into the ground. While it will still be necessary to rake and to pick up all these rocks by hand, the track compacting will save a lot of work. One can also ask the excavator operator to spread a thin layer of topsoil that contains fewer rocks in the basin after track compacting to further reduce the number of rocks that will need to be removed by hand. The crew uses rakes and shovels to smoothen the soil in the basin. They remove all rocks and all roots, and they cut the roots off below the surface of the ground so there's no root protruding that could damage the liner. Before installing the liner and geotextile, remove the center stake and take an elevation reading to make sure the basin was dug at the planned depth. Use shovels or the excavator to deepen or to fill if needed. A one-piece factory-seamed 30 mm PVC liner along with a matching pair of 8-ounce geotextile pads were delivered to the site by pickup truck. A forklift had been used to load the liner and the geotextile onto the pickup truck from where they were being stored in a garage. A long web strap is wrapped around each roll and is attached to the bucket on the excavator. The excavator then lifts the liner and the geotextile pads out of the pickup truck. The rolls of geotextile and the liner are placed near the upper edge of the wetland basin so they can be unrolled while pushing them downhill. Here we're unrolling the first geotextile pad that will be placed under the liner. At least 15 individuals are needed to unfold and to move the geotextile into position. The geotextile is moved until the center of each edge touches or overlaps the pink wire flags that we placed. We pull on the corners and on the edges of the geotextile to remove folds and any bubbles. The first layer of geotextile is now in position. If it's windy, you may use sandbags or rocks to place along the edge to keep it from blowing away. The fish grade liner is unrolled and spread so the edges and the corners of the liner match the underlayment of geotextile. We pull on the corners and the edges of the liner to remove folds and bubbles. The liner can weigh over 500 pounds, so it's a good idea to have many people helping with the project. One should carefully examine the liner for tears and for cuts and the seams for evidence of separation. Any tears or punctures that are discovered, we're going to patch these using waterproof tape. I recommend having at least 2 rolls of this tape on hand when installing a liner, just in case they're needed. Now we place a second roll of geotextile over the liner. It's okay to walk on the liner as long as rocks, branches, and roots were removed from beneath the liner. The top layer of geotextile is unfolded and slid across the liner into position. Everyone present needs to help unfold and to stretch out the geotextile. People need to space themselves out along the edge of the geotextile so no one person has too heavy of a load to move. The two layers of geotextile and the liner are moved so their edges will match. It's especially important that each edge touches or overlaps the base of the wire flags near the center of each side. It's now time to reach under the three layers and to remove the wire flags. The wire flags are likely to dull the blades on the utility knives if they're left in place while we're trimming off the excess liner and geotextile. Elevation readings are taken along the edge and the center of each side of the liner and the geotextile. The elevation readings should match the readings we took earlier at the low edge of the marked perimeter, which is the same elevation as water in the new wetland. A lumber crayon is used to mark an X if the elevation reading is acceptable. I like using a lumber crayon to mark an X showing where to anchor the liner because it's not as messy as using spray paint that can ruin your survey rod and your slacks. I walk around the liner and geotextile to check elevations near the center and the upper edge of each side. If the elevation reading is too low, we peel back a section of the three layers and then we add soil using a rake and a shovel. However, if it's too high, we'll use a rake and a shovel to remove soil. We now drive in a 12-inch long landscape spike where the X's were made using the lumber crayon, and this is to hold the liner in place until we can mark and anchor the rest of the edge. I have found that using landscape spikes that are shorter than 12 inches will not hold the geotextile and the liner in place while it's being covered with soil. We're now using the laser level and the rod along with a lumber crayon to mark X's around the perimeter of the basin. The X's are marked approximately 18 inches apart and they're placed where the elevation is equal to the water level in the wetland that we're building. The 12-inch long landscape spikes are driven into the ground to hold the liner and the geotextile in place while the excavator covers the layers with soil. A landscape spike is placed next to each X to make it easier for the people with sledgehammers to drive them in. I now trim the liner and the geotextile that is uphill of where the spikes were driven in the ground. It works best to cut all three layers at once. The liner and the geotextile are trimmed within 1.5 inches of the head of each spike. I recommend using inexpensive plastic utility knives with 18mm snap-off blades to cut all three layers at once. If you don't cut and remove the liner and the geotextile that's going to be above the water level, then you'll need to find more soil to cover the excess liner laying on the surface of the ground. When you're finished, it's going to look like somebody built a large donut around your wetland, and this is an ugly ridge of soil that will prevent runoff from entering and leaving the wetland. Another reason why you should trim and remove portions of the liner and the geotextile that are above the water level in the new wetland is that there needs to be room for placing 6 inches of soil directly over the top edge of the liner like what you see in this drawing. You're going to need a large trash container to dispose of the corners and the pieces of liner and geotextile that are trimmed and removed. Wire flags are now placed around the edge of the liner and the geotextile so that the excavator operator can easily see where the liner is located and to avoid traveling over it while covering the liner with soil. The wire flags we place show the excavator operator where the edge of the liner is located so they can keep their distance from the edge. Moving the tracks of the machine right up to the edge of the liner can collapse the soil and make a low place along the liner's edge. Here's how the basin appears following the installation of the liner and the geotextile. The excavator begins placing a thick layer of soil over the liner and the geotextile. The operator is careful not to tear the liner with the teeth on the bucket of the excavator. It's often necessary to rake soil downhill to cover the center of the liner because it's beyond the reach of the bucket of the excavator. Under no circumstances should any part of the excavator be allowed to travel over the liner and the geotextile, even if these materials are covered with a thick layer of soil. This elk calf shows us why it's a good idea to protect the liner with geotextile and a thick layer of soil. Where elk or livestock have access to the wetland, one should make the slopes surrounding the edge of the wetland no steeper than 20%. It's also important to place a 6-inch thick layer of gravel over the geotextile and then to cover this gravel with soil. Many other animals can enter a wetland like this and cause damage, including black bear. So that's why it's important to cover that liner with a thick layer, and this will protect it from any damage. We actively monitor the thickness of soil being placed over the liner by using a shovel that has 6 inches marked on the blade. Here is where we're using a shovel and a metal rod to measure the thickness of soil being placed over the liner. The people doing the measuring also show those who are shoveling and raking where more soil is needed and where soil should be removed. The excavator finishes covering the liner with soil while the people with the rakes and the shovels shift soil over places where there's less than 6 inches of soil covering the liner. We purposely leave mounds and ridges to increase plant diversity, and we don't smoothen all the soil that's placed over the liner. The excavator operator uses care to place soil over the top edge of the liner. It's okay to place rocky soil over the liner if the soil is not dropped from high above the ground. I watch the process of the liner being covered with soil to see if the teeth on the bucket of the excavator ever puncture the liner. If this were to happen, we would have to use shovels to expose the tear, to sweep off the soil, and then to patch it using waterproofing tape. The excavator operator has a hard time gauging how thick the layer of soil is that's being placed over the liner. That's why it's important to walk around the basin and to measure the thickness of soil after it's compacted using your feet. We ask the excavator operator to add more soil to the larger places where there's less than a 6-inch covering the liner. The excavator operator adds large woody debris in and around the wetland basin. This wood is carefully placed so it doesn't damage the liner. The trees and limbs placed in the completed wetland are going to provide places for frogs and toads to hide from predators. The large logs that were placed will provide turtles with safe places to bask and waterfowl with loafing sites. We built the wetlands at Michigan Bluff in the summer of 2021. The wetlands filled with water the same winter. The turbidity of water in the wetlands was high the first year. This may have been caused by deer wading in the water. We built the wetlands at Michigan Bluff on top of rocky mountain ridges with little if any watershed. There were many people with a lot more education than me who were certain these wetlands would not fill with water. In September of 2022, the mosquito fire swept through the community of Michigan Bluff, burning 77,207 acres of land that was surrounding the wetlands that were built. The mosquito fire was so hot it killed the trees surrounding the wetlands and even consumed much of the wood that we had placed in the wetlands. This was the first time where a major forest fire burned over shallow water wetlands in the fall when they were the driest. Fortunately, the fire did not harm the wetlands or the liners. The Forest Service replanted the wetlands after the mosquito fire. Here's how the wetlands we built at Michigan Bluff on the Tahoe National Forest appeared in 2024. This is 3 years after construction and 2 years following the major forest fire. You can see some of the rock we dug out of the ground to make the basin for the wetland. Some of the trees that were killed by the fire have now fallen into the wetland. The sedges and the rushes that were planted by the Forest Service are growing. Sierra and tree frogs are using all of the wetlands that were constructed for the project. Sierra and tree frogs are attaching their egg masses to each container plant that was planted in the wetlands following the fire. The eggs hatched and the wetlands are filled with Sierra and tree frog larvae. Dan Teeter made the first observation of two California red-legged frogs using the constructed wetlands in early May of 2024. This is when he was visiting Michigan Bluff with staff from the U.S. Fish and Wildlife Service and from the U.S. Forest Service. The California red-legged frogs were using this wetland that was constructed using a liner. Things only got better when Dan Teeter, Isaac Chellman with the California Department of Fish and Wildlife, and myself observed 3 California red-legged frogs using the same wetland on May 17, 2024. Dan and I went on to find a California red-legged frog using a second wetland that we built using a liner on a different ridge later that same day. According to Dan Teeter, it's very possible the California red-legged frogs are feeding on the Sierra tree frogs. We're very hopeful that the California red-legged frog will use these new wetlands for breeding. Agency personnel often tell me that they wouldn't use a liner to build a wetland because it's not natural. My response is, was there anything natural about how farmers moved streams? And how farmers dug hundreds of thousands of miles of ditches to drain wetlands? Was there anything natural about so many clay tiles being buried in the ground to drain wetlands that if they were placed end for end, they would reach to the moon and back? And is there anything natural about how many of our wetlands have been filled with garbage and millions of cubic yards of soil? I've come to realize that there is no pleasing these naysayers who set up all sorts of roadblocks and preach that it's not natural to build a wetland using a liner. Let's get real and use our best science and technology to build wetlands because we want to, not because we have to. Do you really think this eastern spadefoot cares that the wetland it was born in was built using a liner? Of course not. Don't be afraid of using a liner to build a wetland if you think that using a liner is the best technique available for your construction site. Here's a list of the businesses I've had the greatest success purchasing fish-grade liners and geotextile for use in building wetlands. These companies manufacture high-quality, factory-seamed, one-piece fish-grade aquatic-safe liners with a matching size factory-seamed 8-ounce or 16-ounce geotextile to use in building wetlands and ponds. I have purchased many fish-grade 30mm PVC liners from DAC Liners and from Fab Seal Industrial Liners in the United States, and 45mm EPDM fish-grade liners from Western Tank and Lining Limited for wetland projects in Canada. It's important to cover the liner with soil to protect it from being damaged by sunlight and from animals. An easy way to cover the liner with soil is to use an excavator that has a long enough reach to place soil without having to drive over the liner. This is not always possible because the excavator may have a short reach or the liner can be very large. Some heavy equipment operators will tell you that it's okay to travel over the liner with heavy equipment if there's a thick layer of soil between the tracks and the liner, and if they don't turn the machine while spreading the soil. This is not okay. I've built over 400 wetlands using aquatic-safe liners. You're looking at one of 3 wetlands I've built where I allowed the heavy equipment operator to travel over the liner. This wetland and the others like it did not hold water. I'd like to show you how to place soil over a liner where the liner has a radius greater than the reach of the excavator that you have on site. This method will allow you to cover the liner with soil without having to travel over the liner with heavy equipment. First, excavate and shape the basin as described in this video. Next, place the liner and geotextile in the basin and move them into position, but don't anchor the top edge with landscape spikes. With a large group helping, tightly roll opposite edges of all 3 layers together towards the center. Leave the area in the center unrolled where the excavator can reach in the middle from either side. The excavator operator travels in the basin and begins placing soil over the liner. The excavator will need to make several trips to carry soil unless you have a skid steer with an operator who can help. Here we placed a root mass near the center of the wetland. Volunteers use rakes to smoothen the edges and the ruts left by the excavator in the basin. The liner and the geotextile are unrolled another distance that is within the reach of the excavator for covering with soil. The edge of the liner is anchored and trimmed in sections as the soil is placed. This photo shows a huge 1-acre-sized wetland we built with a liner to provide habitat for the rare gopher frog in North Carolina. The North Carolina Wildlife Resource Commission purchased a one-piece, factory-seamed, 30 mil fish-grade liner from Fab Seal Industrial Liners in Shawnee, Oklahoma. The liner was protected on both sides by 8-ounce geotextile, and then we covered it with at least 6 inches of soil. We used an excavator and a dozer to shape the basin for the liner. Getting the dimensions right required careful use of a laser level and a 300-foot-long tape measure to shape a basin this size for placing the liner in the geotextile. We placed the 2 layers of geotextile and the liner in the basin and then adjusted the edges of the depression to make sure everything would fit as planned. We then rolled up opposite sides of the geotextile and the liner just like a scroll. A backhoe was used to move soil to the excavator for placement over the liner. The basin was raked by hand to remove ruts and ridges before unrolling either side another 20 feet. To accomplish a project this size, you need at least 30 individuals who are willing to work hard all day in the hot sun and the high humidity. Personnel from the North Carolina Wildlife Resource Commission worked very hard to make sure there was at least 6 inches of soil covering the liner as it was being installed. Removing the ruts and the ridges before the next section of liner was unrolled took lots of work. The excavator is making good progress covering the liner with soil. I was very impressed with the work ethic of the North Carolina Wildlife Resources Commission and all the personnel who helped with the project. It is now possible to build natural appearing and functioning wetlands on sites that do not have clay texture soil or groundwater near the surface by using fish-grade aquatic-safe liners. The Boone Holland Wetlands and Nature Trail Park in Moorhead, Kentucky was built on an area where wetlands had been buried under 8 foot of fill to make a subdivision. We used aquatic-safe liners to build this wetland along with 5 others like it at the Boone Holland Wetlands and Nature Trail Park because the soil was sandy and the neighboring ditches were controlling the elevation of the groundwater, and we were not allowed to block these ditches. Here you're looking at a wetland that we built using an aquatic-safe liner on a timber sail log landing on the Daniel Boone National Forest in Kentucky. We used a liner to build this beautiful wetland in southeastern Arizona that's now providing breeding habitat for the federally threatened Chiricahua leopard frog. Abby King, who is working for the Arizona Department of Game and Fish, worked with me to build this wetland using an aquatic-safe liner on the Coronado National Forest in Arizona. The wetland is also being used for breeding by the Chiricahua leopard frog. Here's another wetland we built using a liner on the Coronado National Forest within sight of Mexico that's being used for breeding by the Chiricahua leopard frog. We restored the hydrology in this natural vernal pond by using an aquatic-safe liner. The wetland is located at Kings Gap State Park in Pennsylvania. You're looking at a wetland we built in the desert at Cayush Elementary School in Lillooet, British Columbia, Canada. Again, the wetland was built using an aquatic-safe liner. This is one of many wetlands we built using aquatic-safe liners on the El Dorado National Forest in California. This wetland, like the others like it, are being used for breeding by the federally threatened California red-legged frog. And here's a wetland we built with the help of hundreds of students at Kirksville Elementary School in Kirksville, Kentucky. No one would ever guess that there's a liner buried in the ground. Can you believe that this wetland behind me was built using an aquatic-safe liner 11 years ago? You could never tell because that liner is buried deep in the ground where it's going to last for hundreds, if not thousands of years, providing habitat for all sorts of plants and animals for so many generations to come. We can use aquatic-safe liners now to build naturally appearing and functioning wetlands almost anywhere on the landscape. Well, my name's Tom Biebighauser. I'm with Wetland Restoration and Training, and I invite you to subscribe to this video series so you won't miss any of the future episodes. And please get out there, design, and start building wetlands.